I'm Christopher Murphy. I teach the Precision Farming Labs at Iowa State. Last year we had 138 students in the class. We do anything from displays to SMS software, so we do some mapping software as well. We don't really go into UAVs or aerial imagery. We brought one image in this year just to kind of overlay it with some soil data and yield data from past years.
I'm Zach Vanderleest. I'm a graduate student at Iowa State, focusing on remote sensing with precision ag applications. So, to start with, we're just going to get back to the basics on why remote sensing is a valid point for agriculture applications. Big thing is right now you're seeing a lot of NDVI. We're going into that because it's NIR, which shows a better health response when monitoring plants, and it's flickering.
That's your hearing for that.
Yep, there we go. Okay.
So this is just a regular RGB image. This would be just basically the same as taking a normal photo. It's kind of a good ground truthing when you're looking at the NIR stuff, just to kind of visualize what you're seeing and what you're not seeing.
So next we go into, and just for clarification, these are all 25 centimeter aerial-based platforms photos. So next we go into a near-infrared photo. You start to see some striping patterns. You can really see the turnarounds, and you can see drownouts a little bit better, and you can see those damage in those drownouts is a little more extensive than originally thought. So next, this is the common index that a lot of people are seeing right now in terms of what agriculture is actually using. NDVI, Normalized Difference Vegetative Index. What that is it's math. There's a lot of sensor data behind these images. So you're taking the sensor data from the red band and the NIR, and you're using that formula up there, NIR minus red over NIR plus red. I use a little bit different variant of this formula, but the gist is that in your high-performing areas or your high photosynthetic activity, you're seeing a value of 170. In the drown-out spots, you're seeing about a value of 74.
Basically in this image, if it's above 100, it's vegetation. If it's below 100, it's ground out areas or maybe even weeds.
Yeah.
So this is one of our research farms that we do. As you can kind of see, this was taken June 24th. As you can start to see, you can start seeing passes in the field and stripes. Anything that's a straight line in the image, if you're looking at yield data or even imagery, is human made. So that's when we go out and start doing ground truthing to actually visually see what we're seeing in the image.
So bring this into perspective a little bit. We start with our basic 25 centimeter image. We've got a focus area down there. It's a pretty good area. It's got some high photosynthetic activity. It's got a drown out spot. It's got some turnaround damage, and it's got some other areas where you see some potential damage. Area to the left on here is a later plant date, and throughout the rest of this field, it's a little hard to see with the projector, but there are some planter skips in the field that are visible. So resampled that up to 1 meter pixel size. Start to lose some of that clarity. Damage is a little less obvious. Planter skips are already disappeared on this. And so now we go up to what would be typical value pixel size if you were going to compare it to a yield monitor. This is an 8-row head, or 6.1 meter by 6.1 meter pixel. You've lost almost all the clarity. You barely know that's a drown out spot so much as it just could be regular headland damage. And planter skips are completely gone at this point. And now this is what you would be looking at if you went up to a 16-row head. It's not very good in terms of what most people are seeing for resolution and in terms of field level analytics. And here they are side by side for the same point every time.
So this field right here, as you can see, we got straight lines again. It looks like we have 4 different spots in this field. In the top here, right here, this is actually a grove. So it's very key that you understand what kind of field you're taking the image from. Make sure you take those spots out because that will also change your key across the field. As you can see in the south here, we got lower producing soils in here. And sometimes it looks like up here we do as well. But when you take the image and you separate each track or each different variety, then it's a little bit more clear where our soil zones are. So it's very key that you know what varieties you're planting in the field, because they give you a different greenness value. So it will mess up your keys.
So bringing this back into some other grower potential for quantifying this. So this field we saw a little bit earlier, it's got a lot of drown out spots. This was a late season photo. Approximately 6.4 acres worth of weeds in there. And those 2 drown out spots alone, not including any other damage that you now have to manage for. Just something to be aware of, make it easy to go in, get it dealt with. I don't think this got dealt with before the end of the season, so now we've got to manage for weeds in this area next year rather intensively.
So this field right here, another ISU research field. As you start to look at this image, you can start to see a 45-degree angle through this field. Our ISU dairy is over in this corner. They were doing drag line applications in the spring, this past spring. And you can see exactly where that tractor passed in the field. So just seeing this data here, we decided to spend a little bit more money and ship that manure further down to better soils. So just that knowledge is helpful. You can also start to see like a little bit of an angle here. That's actually the field cultivator. It was a little too wet when the field cultivator was in the field as well. So it does matter when you actually do take these photos. So we did this before canopy on the corn, so you could see the actual compacted areas. When we took it in July, you can kind of still see it, but you can't, it's not visible enough to actually make a judgment call off of that image. If we zoom into the area even more, so right here, there is actually a hybrid change or a variety change between these areas. So this is hybrid A and this is hybrid B. So it's also very key that you check it with your planning data so you actually know that that was the change. We actually had the farm manager sit down with us when we got this imagery, and he's like, oh, there's a variety change here. He knew it right away. So, I mean, it's very key that you know what you're doing, make sure you check with your planning data, verify this information.
I just have a quick question. How did you know that that was compaction from this year?
We're getting there.
Oh,
So one of the ways we started to tell is we went into the field, we started to measure the striation that you saw. On average, there was 10 to 14 inches in plant height variation in the compacted and uncompacted zones. This image was when they were right next to each other, or like right down the middle of the compacted and non-compacted. Yeah, I'm red-green colorblind, so this doesn't help, but I mean, you can see the lines. I can't. We'll go with that. Again, started digging around in there a little bit, and we got some difference in the root ball size. This was one of the more extreme examples, but again, the one on my right, your left, or actually I guess it'd be everybody's right, is from a non-compacted zone, and the one on the left is from a compacted zone. So you see quite a difference in the root ball size.
And I guess we won't really get to that. They knew they applied it at that angle. They crossed the rows, so that's how we knew it was applied with manure. So that's how we knew that the 45-degree angle that you're seeing here,
yeah.
that's how they applied the manure in that field.
Were there any soil surveys done to this particular field that would help with that?
They didn't get out of this field in time for me to do soil surveys this year. It was really wet, so it was a late fall harvest, and by then it was too cold for me to get in there with the soil probe.
So we did some ground truthing in this field. So the high productive areas, we went out and did some ear sampling. So in the high productive areas of the field, it averaged 195 bushels per acre. Then we went to the healthy plants in the compacted areas. That averaged 160 bushels an acre. Then we went to the non-healthy plants. That averaged 145 bushels per acre. So we did kind of just the quantifying the practices here. It's a 120-acre field. If you figure 70% was compacted, times 100 or times 15 bushels per acre loss in those areas, it's 1,260 bushels, which is about $5,000 in loss in that field. That image only cost us $240. So this is another tool that we kind of use. We don't go off of it totally. So in 1995, they made soil sample data digital. Does anybody know when those soil samples were done? Anybody? You smile.
Don't they usually do them from the spring or before that season?
So these were done in the 50s and 60s. With
Oh,
a
they're not doing them.
Right, these aren't
No.
soil, these are soil surveys for soil taxonomy, or
Yep.
soil classification.
So they were done in the 50s and 60s with a bucket and a chart. So I teach the precision farming class. Last year, we had people all across Iowa with fields. There was 100-acre fields that had one soil type in the field. So it's good when you get good stuff like this, but you don't want to go off of this and create a variable rate planning map off of that, because you're going to run into issues and you're going to underproduce in the high areas of soil. So just always remember, it's a good tool, but you got to have something else with it to verify.
So, the state of Iowa is pretty generous in that it provides the entire state free 1 meter LiDAR data. And a lot of the tools out there right now have overlays, or overlay capability. This is a 3 meter satellite resolution Google Earth image that's overlaid with LiDAR data, and it's great for starting to get some of the terrain feel. Well, it also helps to explain some things that aren't as obvious when you're in the field. So take that, because this field did get soil sampled this fall, with the current levels of organic matter, and you see that our hills, or the high zones here, are red, while the low valleys are green, which is what you would expect with organic matter distribution. Again, so we took it with the NDVI, and you can see red zones are exactly where we think they would be with low-lying areas. And the green with highly productive areas are your sandy hills, because it was such a wet spring and summer.
Some general recommendations: acquire good imagery, and then make sure you ground truth your data, because else you'll really never know if it's actually good data or not. Is there any questions?
So, actually, two questions. 25 centimeter pixel, is that the standard that you would recommend?
So we actually didn't have our COAs in place until fall this year. So we didn't actually do any UAV flights. We only did GeoVantage flights. So we did all contract flights. We did some 50 centimeter stuff, but the 25 centimeter just gave us a lot more compacted areas and was able to find those zones a lot better, is what we found anyways.
I can also tell you that if you want to try and fly 25 centimeter without doing it in a software, that's going to put you at about 2,000 feet to fly that.
Oh, wow, okay.
Yeah, so I'd stay away from
What's
that.
possible at, say, 400 feet?
400 feet, you should be sitting at about 6 centimeters, I believe.
6. Okay, with the drone.
And again, that depends on the camera capability that's carrying, but that's just a quick off the top of my head one.
Have you guys used any of the satellite imagery in comparison to this?
So right now I'm actually taking a class on that. I'm going for my master's. And I am not that impressed with satellite data after seeing 25 centimeter data. I mean, it's good for finding zones, but when you're looking at 5 meters for resolution, you're not going to see that compacted area in the field. You're looking at the same thing you're seeing with yield data. You're pulling 40 feet into one point.
Yeah, and I mean, so Landsat provides free 30 meter data, which is going to be worse than that image we showed with a 16 row head, and then there's some stuff from, I think, Digital Globe that can get you to 50 centimeter now, but I went and looked at trying to supplement a data set with that, and the one field I needed was covered with a cloud, so like the one in the entire area, only cloud in sight.
So, are you guys looking at uses of I don't know what they call that system that uses the blades in the ground to measure drought resistance, but the mapping that they do with those.
Oh, like a Veris, so like soil EC.
Yeah, we actually used one on a couple of our fields already.
Yeah, the
so.
one with weeds we had in there, we've got EC data from. So,
Are you seeing pretty close correlation between what ends up showing up visually and the stuff that you're seeing with those maps?
to an extent, it matched the organic matter content from the soil sampling very well, and it matches LiDAR data in terms of seeing how things are distributed. It was fairly consistent with that as well. It was just actually being able to put a number to that was nice. So,
Could I see a particular slide here?
yeah.
The equation where you figured out your yield loss, 20 acres times 7% compact multiplied by.
Yep.
Were you using the LiDAR just for fields or were you using it for applications as well?
So we didn't play with that much this year. We mostly bring it in as a visual aid right now in terms of showing people what's out there, why they want to use it, stuff like that. It was just one of those things. It was a busy summer, so we didn't quite get to that, but it's been a very nice visual representation for showing people after the fact. So,
Do you have any softwares you're working on for determining other factors within it, like perspective or anything like that?
so play with, so I work with ArcGIS and ERDAS Imagine a little bit. In terms of hyperspectral, I haven't gotten to play with any of that yet. I know it's nice data, but it's expensive if I understand right, so.
We're hoping to actually do some UAV research this summer, so now that we can actually fly it, so.
When did you guys get it going?
November.
Yeah. So, a little too cold for crop flying.
The crop's out already.
I'm sorry for monopolizing the question.
It's all good.
There's no handbook for understanding which patterns of striations in your images account for what kind of problem. But what I gather is that to figure out it was compaction, you looked at what was going on, you had a record of what was happening in the field, and then you looked at the plants and found the.
Yeah, so a lot of things, as you're working with these fields, you need to be talking with the farmer because the farmer knows what he's done in that field for the last 20 years. He's known how he's planted it, he knows which direction he's planted it. Just 3 years ago, we switched from going east to west in one of our fields to north to south. So, it's just, you need to talk to the farmer. You're never gonna know, we would have never known that was manure application if we wouldn't have talked to the farmer or the farm manager. So, that stuff you just need to kind of do. You can see the turnaround rows of the planter and stuff on some fields, but other than that, we're gonna overlay some planning data. We have that stuff and we can do that within SMS. So, we're gonna,
Farmers likely know what he's looking at if you show him.
Yeah, or at least be able to give you an idea. Again, with the planning stuff, we went back in and we've got planning data for all these fields, so we can start to pick them apart and look at the individual varieties in terms of reflections patterns instead of comparing them with each other. And just, because you really shouldn't try to compare them to each other, it's gonna cause problems. Again, keep in mind, these are all visual representations and there's actual data behind it. So in terms of you're wanting to analyze it by visual representation, you need to take it apart a little bit and look at the individual varieties for performance instead of trying to compare them, because a lot of the varieties, like you said, they have different greenness values in the leaf, and so they're going to reflect differently. So if it reflects more light, it's going to cause problems because it's going to appear brighter, and if a neighboring one absorbs more light, well, you get the idea. So
What's on the wish list of sensors outside of NIR for next year? What are you guys looking at?
So, one of the big things that we're looking at is just high temporal resolution over anything else, identifying critical timing. So just the ability to fly every week affordably and be out there is going to be critical.
from previous research, I did some research at Iowa State. We did some return on investments for planters and percent error that you would see, and then also tillage equipment. My boss is very into doing return on investment. What is the best dollar figure? Is the farmer going to see something from buying an EB and flying all of his fields, or a DG Phantom, or what? I mean, that's what we're kind of here for, is doing that kind of stuff. What's the best way to do it?
So, in terms of other sensors, I know GeoVantage, at least on their website a couple weeks ago, was advertising, I think, a thermal camera now, so we might be trying that a few times. We'll see if that's actually available or not.
And since we couldn't fly our own, we were limited to what we could fly with a contract flight, so.
Yeah. So,
Is there such a thing as like a catalog of plans and their spectral,
Yes.
what?
so if you Google, what's it called? If you just Google like a spectral curve for corn, it should pop up with something, or spectral reflections curve for corn. Most of the plants do have a general signature, but they're not variety specific. So,
Any other questions? All right.